Part 2 now of our special quadrilaterals lesson. We're going to look at 3 different examples, 3 different types of special quadrilaterals. I suggest that if you haven't managed to copy down and try these exercises already, that you do so now. Pause the video and see if you can work it out and come back. Okay, so we're given that ABCD is a rectangle. Obviously, there are lots of properties of the rectangle that are not reflected on the diagram here. So it says AC is equal to 10. They haven't drawn that on the diagram because it would be a little bit messy if we do that, so I'm going to leave that for now. BC is 8 centimeters is there, and angle D2 is 20 degrees. So they want to know A2, A1, C2, AE, and AB. And if you think that that sounds like a lot, then I suggest that you look at exercise 4b in the book, because there they ask for every single angle in this problem. And I just thought that was a little bit much. So you can thank me when we see each other next in person. Okay, so firstly, we know in a rectangle that the diagonals are equal in length. So that means that each of these individual segments, AE, is equal to EC, is equal to ED, is equal to BE. What that gives rise to is that triangle AED is now an isosceles triangle. So I end up having angles up equal sides. Angle A2 is equal to 20 degrees. Right, so let's see how we write that down. All right, so I've got my A equals EC equals B equals ED. That's what we showed on the diagram. Therefore, A2 is 20 degrees. Angles up equal sides. And I just wrote triangle AED to be very clear which triangle we're talking about. But if you left that out, that would be okay. Right, so that's A2 done and dusted. A1 is the adjacent angle to A2. And we know that in a rectangle, the interior angles are all 90 degrees. So if A is 90 degrees, then A1 has to be 70 degrees, subtracting 20 from 90. Okay, so writing that down, angle A is 90 degrees, interior angle of a rectangle, therefore A1 is 70. And if you want, you could write adjacent angles, but you don't really need to do that. Okay. C2. Now C2, there are lots of ways that you could do this, but I think maybe the most straightforward is that I have a Z shape here, backward Z shape, which means that C2 forms an alternate angle with A2. So that means that C2 has to be 20 degrees. But to be able to use this, I need to state which lines are parallel. So I need to show that AD is parallel to BC. We know that our reason there, opposite sides of a palm or opposite sides of a rectangle in this case, we can be more specific. And I've just covering my bases, I've just written both pairs of opposite sides are parallel. That means that if I need the other pair of opposite sides later on, I don't have to rewrite it again. So therefore C2 is 20 degrees, alternate angles AD parallel to BC. Right, AE, now we want the length of AE. Well, they told us in the beginning that AC was 10 centimeters. And we stated already AE is equal to EC, which means that this is bisected. So AE has to be 5 centimeters. AE is 5 centimeters. And I've just written again diags of a rectangle, even though we already wrote it up here. I've just written it out again for completeness. Lastly, AB. I can see that AB is this side length. So if I know that this entire length, AC, is 10 centimeters, I have BC is 8 centimeters, so I can work out my third side using Pythagoras. But I need to first state that this angle B is 90 degrees, because without that, Pythagoras doesn't mean anything. I can only use Pythagoras with a 90-degree, a right-angled triangle. Okay, so angle B equals 90 degrees. That's my interior angle of a rectangle again. I have my Pythag statement. Then I sub in. You could actually just do this step for the marks, but you must show the substitution, and it must be a plus here. AB squared is 36, AB is 6 centimeters, don't forget your unit. So there, from something that looks sort of long was actually pretty straightforward, and this would probably be at least 5 marks, if not probably more than that. So a nice easy one to get you started. Okay, exercise 2. If you haven't done this one, pause the video and see if you can work it out. ABCD is a rhombus, which means that there are lots of properties here that are not shown on the diagram. We're trying to work out what this little angle C2 is. And I have some information about DEC and C1. So I see that I could work out angle D, some angles in a triangle. That wouldn't be a bad way to start out. But before I do anything, I'm going to look and see what properties of the rhombus they've kind of given me a hint about. So they've numbered A1 and A2. I'll probably have to use those somehow. And not only have they numbered C2, but they've also numbered C3. So that's kind of a hint that I'll need to use those. Whereas like this other angle AEC isn't labeled with a number. So it's unlikely that I'll need to use that one, right? AC is a diagonal, and I know that the diagonals in a rhombus bisect the interior angles. So that means that A1 and A2 are going to be equal, and C3 and C1 plus 2 are also equal. I'm not going to show that one, it's going to get a little bit complicated down there. I also know that because a rhombus is a special type of parallelogram, that I have opposite sides parallel. So I'm going to draw that on my diagram, and as soon as I draw that, it opens up a whole range of opportunities for me in terms of alternate and co-interior angles. So I suddenly see that I have a Z shape here with the 75-degree angle that I was given, which means that this angle C2 plus C3 has to be equal to 75. Now, looking at all of angle C, that means that all of angle C is equal to 75 plus 25, which is 100. And if I work across the rhombus, that means that all of angle A also has to be 100 degrees, because opposite angles in a parallelogram, in this case in a rhombus, are equal. But we just said that A1 and A2 also have to be equal because the diagonals of a rhombus bisect those angles. So that means that if it's bisected, 100 divided by 2 gives me 50 degrees here and 50 degrees here. So we're trying to figure out C2. I know that the big angle is 75. So if I can work out C3, then I can subtract, and we see that C3 is alternate to A2. And I have another Z shape there, which I can highlight in another color. So A2 is alternate to C3, which means that C3 has to also be 50 degrees. So hopefully you can see now what C2 has to be. 75 minus 50 gives me 25 degrees. Now there are lots of different ways. To do problems like this, and I can't remember if I said it before, but I'll say it again. All of these, including the book answers and everything that I show you in terms of solutions, these are model answers and not the be-all, end-all solutions. So that means if you do something different, it's not necessarily wrong. It's just you had a different way of looking at it than I did or than the authors of the book did. So you're always welcome to take a picture of your solution, send it to me, and we can see, I'll have a look and give you some feedback. Okay, so let's look at how we would write out my solution. It's a little bit off, move it over. Okay, so we started off by saying the opposite sides of the rhombus are parallel, and just for completeness, in case I needed them again, I wrote both sides. Then we said C2 plus C3 was 75 degrees because it was alternate to this angle DEC. Then I worked out the entire angle C, 75 plus 25 gave me 100, and said therefore the opposite angle A was also 100 opposite angles of a rhombus. Therefore we said A1 equals A2 equals 50 degrees. Diags of a rhombus, we know that they bisect the interior angle. So C3 was equal to 50 degrees. That was my other alternate angle. Same parallel lines. And you could have AE here, that's fine. Therefore, you could have just gone straight to the answer, C2 equals 25 degrees. And I've just given some completeness from line 2 above, so from the C2 plus C3. But honestly, if you had just had angle C2 equals 25 here with nothing else, you'd get the mark. Right. Last one, exercise 3. Now we have a square. PSRQ is a square. Again, pause the video if you haven't tried this one yet. PSRQ is a square. PR is a diagonal. So already, I'm going to write down what we know about the diagonals of a square. We know that they bisect the interior angle, which is 90, which means that, let's do it for R2, has to be 45 degrees. That means that R1, P1, and P2 are also 45 degrees. Now I'm going to solve this. We want to know what V1 is, and I see that V1 is vertically opposite to V2. So straight away, hopefully you're seeing the solution here. I have triangle VSR, and I can do some angles in a triangle to work out that V2 is 95. Therefore, V1 must also be 95. So it's sort of a complicated drawing for really not a very complicated sum. Let's look at the solution here. We said R2 was 45 degrees, diags of a square. V2 was then 95 degrees, some angles in a triangle, and I've been specific, said triangle VSR, but if you just had triangle there, that's fine. Therefore, V1 was 95 degrees, vertically opposite. Now, some people might have seen it in the top triangle, so let's look at that as well. In the top triangle, okay, pretend we don't know V1. We have P1, we said was 45 degrees because the diagonals of a square bisect the 90-degree angle. We have PQ parallel to SR because it's a square and opposite sides are parallel, which means that this angle S2 is alternate to T, 40 degrees, and I can do some angles in a triangle to get V1. So, lots of ways you could go about it. There's that solution. Again, there's no perfect solution here. There's just lots of different alternatives. And that's one of the things that makes geometry kind of cool, because we can approach a problem totally differently and get to the same answer. Right, so from there you should be able to do the exercises that I allocated for you in exercise 4, and we will come back to it in a couple days' time. Good luck.